Hello, welcome to this video. In this video, we are targeting to answer only one section of this paper. Let me show you where is this section of the question is found. It is taken from IGCSE Extended Maths from the series of May-June year 2022, paper 4, variant 1. The section that we are going to look at is this. Okay, we just read through, just give us an idea what is this questions about. A new table with different class intervals is completed. I was given the table there. On a histogram, the height of the bar for time t between 40 to 90 interval is 17.2 centimeter. Calculate the height of the bar for the t between 90 to 150 interval. And the answer is supposed to be given, of course, in centimeter because they ask for the height of the bar. Now, in order to approach this question comfortably, I would like to provide us with an overview about what is histogram. We won't go into detail because that is for another time, but in order just to know what do they talk about, what is the height of the bar, and basically the height of the bar is this height, okay, or this height, okay. So as you mentioned just now, I scrolled up and I show you that there are two types. Yeah, and both types, yes, they indeed have the height of the bar, but which is the one that the questions is referring to. So now, in order for you to understand better what are they talking about and able to rack in the full marks, we will see first and compare the two types and which type this question is talking about. On the horizontal axis, the x-axis, we notice that it is referring to the whatever data that we are surveying. In this case, age, probably age of people, but for these questions is talking about time in minutes. So of course, for this particular case, this part will be the time in minutes and the time in minutes. Then we haven't zoomed in which type are they referring to. Okay, let's see the difference. The first histogram, the vertical axis is showing frequency, meaning how many people within this age group, and then how many people, for example, in the age between 50 to 60 age, and that is frequency. So this is the histogram that we learn when we are at the junior years, probably at year 9, okay. And now in KS4, we are learning the second type of histogram, and we notice that the axis is no longer showing frequency, therefore it is not as directly able to plot the histogram. We need to find out from the frequency table frequency density. So there is a new thing that we have to find out because it is not as direct as the previous one. So in order to approach that, I would like to take us through two background information that are required to deal with this question. The first one, what is frequency density? Second, representing the height of the bars, and in this case, of course, is frequency density by centimeters. So let's hop into it. So basic information, one of two. The first one, what is frequency density? So I've shown here, this is the formula of frequency density. It is quite straightforward, all right? So it is very simple, and let us just get ourselves acquainted and able to remember them. Okay, so the firstly is the taking frequency divided by class width. I repeat, frequency density equals frequency divided by class width. Okay, and I've get some practice question which is from the previous section of the paper just now. Okay, we were given a frequency table. Well, within this this is the time in minutes, well, and then this is frequency was given within 40 to 60 minutes there are probably 6 students and so on. and between such, for example, 80 minute to 90 minute, that's 70 student. Okay, so that's frequency. But if we plot the frequency, if this is time and this is frequency, then no problem. We can just directly take this information and plot into. So there's no additional calculation required. But now we are not dealing with the first type of histogram. Now we are dealing with the second type with the frequency density. Therefore, we need to understand how to get the formula right and then get them into our memory. And let's practice this. Okay, so let's take let's take on the K. All right, let's practice with this. So this is called interval. All right, and then this is called interval. In the question I mentioned interval. Yes, it is between 40 minutes to 60 minutes. This is all interval. These are all interval, and they also have another name which called class width. So class width and interval are actually same meaning. Okay, so let us just to start practicing. Okay, so let us first indicate here what is the class width. Let me move this down a little bit. Okay, to give us some space. Okay, so in order for you to get it done quick, in a quicker manner, let us just indicate on top of the table. You can do this also during exam. Okay, so the class width meaning the word width or itself telling you the upper class and the lower class how wide they are. Meaning, what is the upper class? 60. What is the lower class? 40. So you just take the difference between them, and that is, so 60 minus 40, and there you go. So you got 20. That is the class width. And let's go on with this. So this is 80 minus 60. You may go on and pause the video and then work this out and join me later. So let's go on. 80, so this is 10, and practice some more. Class width for this is 100 minus 90, and the class width is 10 minutes. And this, what is the class width? The upper class minus the lower class, the class width is 50. Now let's go for class. We have already done with the class width. Let's move on to frequency density. Okay, so as the formula, let's go through and take a few one more time. Frequency divided class width. So let's go on and work on that. Okay, so let's just also for simplicity's sake, so we just put in frequency density below the table, and we know that the formula is frequency divided by class width. So for this interval between 40 to 60, the frequency density is 6 divided 20, and that will give you can get that answer from the calculator, that is 0.3. So this is frequency density. Alright, and let's move on, more practice. So again, frequency for this 10 divided by the class width 20, and frequency density for this interval will be 0.5. You may pause video now and join me later. Okay, there's 3 more for you to practice. Okay, so for this interval between 80 minutes to 90 minutes, what is the frequency density? Simply take the frequency divided by the class width. Tada, you got that, 0.7 unit. Let's move on, more practice. For this, wow, there's a lot. Okay, there's a lot of students. Okay, that probably know whatever they do, whether it's they finish their exam or whatever within that time frame, between 90 to 100, 84 of them. And let's work out their frequency density. So it is 84 divided by 10, and that's comfortably 8.4 unit of frequency density. And let's move on to the others. The last one, the last practice, just take frequency, divide class width, and that is 0.6. There you go. So these are the practices for all of us to get comfortable to get frequency density from the frequency table. Okay, in exam they usually provide us only the frequency table, but we have to know this formula, frequency over class width, in order to work out the frequency density. Let's move on to the basic information number 2, which is to representing the height of the bars. In this case, is frequency density by centimeter. Okay, before we hop on to frequency density, probably is a new word to some of us. Well, let us just illustrate this with something more familiar. I'm using mass, kilogram. Okay, so in order to represent that, so I say that, okay, the question mentioned to us, 5 kilogram is represented by 2 centimeter. If 5 kilogram is represented by 2 kilometer, and they ask us to calculate 12 kilogram is represented by how many centimeter. Okay, this is a very simple idea, which I know that most of us could be very familiar with this. Well, let's just hop on to approach this and solve this. How many centimeter representing 12 kilogram? And then in this context, in terms of mark, it doesn't matter which method you use. Okay, some students prefer the method number 1, some prefer method number 2. However, the assurance is it doesn't affect your overall mark scheme. Okay, so what you can do, let's say if to choose method number 1, how do we do that? We just find out 1 unit, 1 kilogram, 1 unit, unitary meaning 1 unit. 1 kilogram represented by how many centimeter? Okay, that easily, I'm sure we can comfortably take that by, okay, you're going to take 2 centimeter. Okay, because they mentioned 2 centimeter represent 5 kg. Now you want 1 kg, of course you're going to divide by 5. And so that is the centimeter representing 1 kilogram. And you hop on to find out from the question request, 12 kilogram is represented by how many kilograms? So surely you will multiply this. Okay, and in this case they want 12. So let's just go on. So that's 24 divided 5. So you're going to get 4.8 centimeter. All right. So this is the first method. This is our method 1 to find out that representation in centimeter for 12 kg. If you wanted to use the direct proportionality method, it's absolutely okay. Alright, so in this method, what you're going to do is you just take like, okay, 5 kg is related or represented by 2 centimeter. Now you require to find out 12 kg represented by how many centimeter. Okay, let's just put an X there. Okay, so in order to find the X, what you need to do in direct proportional, we know that we just put them in the equivalent ratio. Alright, so we just put them in this way, and then in the equivalent ratio, and in one simple shifting around of the equations, then you get 4.8 centimeter. Okay, here we go. So you can comfortably choose. Okay, no pressure, you can just choose whichever method that is comfortable and confident for you. Alright, so now let us proceed, apply this skill in this context. Okay, now I'm just going to say that it is mentioned the height of the bar, of course, the height for frequency density 0.5 unit in histogram is represented by 12.4 centimeter, and calculate the height for frequency density 0.9. Well, just use the whichever method, doesn't matter, but for the sake of learning, I'm going to demonstrate for your choice both methods. So this one, you're just going to find one frequency density. I'm just going to short form in FD for frequency density, is represented by how many centimeter? Going up here, they say 0.5 frequency density is represented by 12.4. So you take 12.4 and divide this by 0.5. Okay, because you want to get 1 unit. Okay, so 12.4 divided by 0.5, and there you go, you got 24.8 centimeter. And let's go on to, if you wanted to see or choose direct proportional method, you can just take frequency density. Let me just put a title here, easier for your reference. If frequency density 0.5 represented by the height in cm, how many? 12.4 cm. And now you need to find the height for 0.9 and what is the centimeter that represent it. So let's put them, arrange them in equivalent ratio. Okay, so let's put in, excuse me. Alright, so now let's go on. So x over 12.4, so in the equivalent ratio, we just put in there, and with another simple twisting of the equation, multiply the 12.4 over, and you're going to get same answer. Okay, so this is the basic skills and the background information you require to approach that. Now, since we have acquired the both of the background information, why not we just approach that questions? Okay, now let us read through this again, but this time with more background information to you, and you may find the questions brighter because you understand more of it. Okay, a table with a different class interval is completed. On a histogram, the height of the bar for time between 40 to 90 is 17.2 centimeter. So this is the one. Okay, so this bar is represented by 17.2, and so the question says calculate the height of the bar for the time 90 to 150. Okay, so in other words, you need to find the bars for that. Okay, so let's put that, give you some pictorial representation. Hopefully that gives a better understanding. If I were just to sketch, okay, so it is something like, okay, we have, this is the histogram, all right, and we won't sketch everything. This is time in minute, and let's say it was given to us. Okay, let me put this also 17.2. So there is a bar. There is a bar. Okay, let's say probably like this. Okay, this is the bar. This will be the frequency. Okay, short form here, density, and this is between 40 to 90. And according to the frequency density, we do not know yet. Okay, but it was mentioned to us the bar here, this height is how many? 17.2 centimeter. So that was what they meant. Okay, so now they asked us what is the height. Okay, what is the height for that time for 90 to 150. So you notice that you need to relate the centimeter to frequency density. So what is the next thing you do? Yes, you need to get this height relate to frequency density. And frequency density for which group? For this interval, 40 to 90 minutes. So this is where you will put on your formula into use. So let's going to illustrate that. So let's find the frequency density. Frequency density for which group? For 40 to 90 minutes. Okay, you're going to find this out, and of course, what is the formula? Frequency over class width. Alright, so you just go up there to the table. What is the frequency there? Okay, 86. What is the class width? You have learned that just now. Okay, the class width, let's just put a short form here. Yeah, class width will be 90 minus 40. Correct? Yes, we got the same idea, right? So the class width is 50. So we're going to take that 50 and slot into your formula here. And then let's go on. Let's get it out. 86 divide 50, and it is 1.72. So with this, what is the meaning to it? It is simply, okay, let me just okay, so what is the meaning of 1.72? It is here. 1.72 is here. 1.72. Alright, so this is the frequency density. For which group? For which interval? Between 40 to 90. Okay, so this is the meaning. So now you manage to relate that, okay, frequency density, okay, frequency density of 1.72 unit is represented by the height of how many? 17.2 centimeter. Okay, this is the information that you are going to work it out, and because you are working it out, there definitely are marks there. Okay, so be assured that you will not be working in vain, because by looking at 86 divided 50, there is some mark rewards there. Okay, now let us go on to deal with the one in light blue, the one that they asked. Okay, of course, let's say we do not sure. Okay, we do not sure. Let's say, okay, what is the height? Okay, so let's say this is, would that be taller? Would it be, okay, so this is the time between 90. Okay, I'm going to join it from there. Okay, so 90, probably from here. So 90. All right, so 90. We're not sure whether is it taller or is it shorter, but let's go on and find out. We will definitely find that out very soon. Okay, so it is between 90 to 50. So now we are talking about this block. All right, so they are asking what is the centimeter for that one. Okay, so let's go on to make it clear for you. What I'm going to do, I will use light blue pen also, and this time I'm going to take frequency density, but this time let us find out what is its frequency density, because we need to fill in the blank here. Then with this blank, okay, once you fill in here, we are going to solve this. We're going to get the answer for this, okay, but not yet D, okay, not yet solved, but we're going to solve. So now, in order to get that, let's go on, bring out our formula again, which is frequency. For revision, I'm going to write that again, frequency density, and explain what is the frequency shown on the table. 114, right? Let's bring that in, 114 over or divided. What is the class with? Okay, you tell me. Yes, upper class 150 minus lower class 50, that is 60. Got it? Let's take that 60 down and fit into the class width, and let's go on, get some help from the calculator. 114 divided 60, we get that as 1.9. okay, so now we can take this and fit into here, 1.9. okay, so now once you get that 1.9, and then you're going to find how many centimeter. Okay, and this is the time you can use whichever method that's comfortable to you, either unitary method or direct proportional method. It does not matter, because it's going to lead you to the same answer. So now let's go to find this. Let's say if I would to demonstrate both. Okay, let's do that. Okay, let me shift to give some space over here. Can we take this down? Alright, so I'm going to use, let's say, the method number 1. Okay, unitary method. Okay, choose whichever that is comfortable to you. So for unitary method, we will just take one unit frequency density. How many are they representing? So you take, this is 17.2 divided by how many frequency density? 1.72. So that this amount representing 1 unit, and now you need the height for 1.9. You just multiply 1.9. Exactly, yes. So you just take, so now 1.9 unit frequency density represented by how many? You just put 1.9 multiply, just take whatever that is represented here, how many centimeter there. Okay, and with a few punching of the calculator, 17.2, and then divide by 1.72, it's 19 cm. Okay, so here, this is the unitary method if you want to move on that. Okay, and so in order not to erase this, what I'm going to do is I will go forward to the I will just go and replicate this to show, in case any one of us are comfortable with the direct proportional method. Okay, let's show that also. And once you got both options, you may choose whichever that you want. Okay, proportional method, and with the great assurance, proportional or proportionality, of course, the answer will definitely be 19 centimeter also. Okay, let's assume this is an x. Okay, so it's putting the equivalent ratio 17.2 equivalent to 1.9 and 1.72. with the flip of the formula, 1.9 divide 1.72 multiply 17.2 and punch a calculator, 1.9 times 17.2 and divide 1.72. Surely your calculator will show the same answer, 19 centimeter. Okay, so that's all that you need. Okay, so let me just partition it to make it clear for you. All right, so this is the overall approach. Okay, and then here also, if you're comfortable with the unitary method, okay, that's it, you can choose it. Okay, so that's all for this video. So you may look for other similar questions where they take histogram, but they ask you to find the height in centimeter. So now hopefully this will enlighten you that it is no longer a difficulties, but now you know. In short, in summary, okay, what were you going to do? Okay, so in short, let's say an overview. Okay, what do you need to do? All right, first, from the frequency table they give to you. Okay, they give to you. What you do is use the frequency density formula, convert that into frequency density. Okay, and then from that frequency density, you relate that height, you relate this frequency density, relate it to height in cm. Okay, and then once you relate that, third and or the last, you can use unitary method. Okay, if you can't remember, you can just rewind the video. Unitary method, or method number 2, direct proportionality. That's a long one. Okay, so to get the answer. Okay, but before we end, let us do a final revision. What is frequency density? Got it? Yes. Okay, let's revise. What is the numerator? Frequency. What is the denominator? Class width. Got it? Yes. Okay, so let's just box out this formula because that seems to be the deciding factor to your full marks. Okay, so that's all for this video. So hope you enjoyed this, and most important, it helps you in acquiring full marks. Alright, so I'll see you in some other video. Okay, bye bye.